Hello class 7 students. How are you all? I hope you all are keeping well. I am Priyanka Singh, your science teacher. Today I am here to start with the chapter 7. From this chapter, unit 3 is starting, the world of the living, and the name of the chapter 7 is soil. Soil, like air and water, is one of the most important natural resources necessary for life on earth. Soil supports the growth of plants and trees by holding their roots firmly and by supplying them with water and mineral nutrients. Soil is also the home for microorganisms like bacteria and fungi. Soil beetles, soil mites, rodents and earthworm, millipedes, centipedes and termites. Formation of soil. At beginning, the earth crust was made up of thick layer of rocks. Sun heats these rocks and rain cool down them continuously. This process of heating and cooling cracks the rocks. When it rains over the cracked rocks, the rainwater can get its place in between the cracks of rocks. In winter season, water is converted into ice. Ice is the crack of rocks expand and cause the rocks to break into smaller pieces. Rock contains some minerals or chemical substances which are oxidized by the oxygen present in air. The oxidized mineral crumble easily. These small particles are carried by air or by running water. Sometimes the roots of plants enter the cracks of rocks, and to grow they need space and hence break up the rocks. The acid produced by the roots of some plants also help in breaking of rocks. Many microorganisms also help in breaking of rock. Many microorganisms also help in the weathering of rocks. Various natural processes such as earthquake and volcanic eruption break down rocks. The breaking down of rocks into smaller pieces by natural factors like wind, wave, glacier and rain is known as weathering of rock. Thus, the soil formation begins with the breakdown of rock and other material into smaller pieces at surface of earth. The factors due to which weathering is possible is termed as agents of weathering. Water, air, wind, plants, rain are the agents of weathering. The smaller particles of rocks undergo various stages of corrosion or decomposition by various natural processes such as reduction, oxidation, hydration, hydrolysis, etc. Composition of soil. Soil is made up of mineral particles, inorganic substances and organic substances, humus. The particles of soil or broken rocks can be in different sizes. The composition of soil depends upon the types of rocks from which it is formed. Due to the presence of different minerals, materials and organisms, soil has different physical and chemical properties. Mineral particles. These mineral particles are gravel, sand and clay. Gravel has very fine grains. Sand grains are smaller than gravel. Clay is made up of fine grains which stick together. Many particles of the soil determine the texture and type of soil. Inorganic substances. Nitrate, phosphorus, sulfate, carbonates of potassium, magnesium, sodium, iron or many other salts are the components of soil. Organic substances, humus, by the various activities of plants and animals and their death and decomposition creates organic material mixed to the soil. The completely decomposed products of plants and animals is called humus. Organic substances make the soil fertile and improves its water holding capacity. Living organisms. Tiny plants and animals like scorpions, centipedes, millipedes, earthworms, etc. are found in the soil. When these organisms die, their decayed remains get mixed up with the soil. Water. Water is present in the spaces found in between the soil particles. The water building of a soil depends on its texture. Water is needed for good growth of plants. Soil profile. We usually see the top surface of the soil, not the layers below. If we look at the sides of a recently dug ditch, we can see the inner layers of the soil too. Such a view enables us to see the soil profile at a place. A vertical section through the soil showing the different layers of the soil is called the soil profile. Each layer differs in feel, texture, color, depth, and chemical composition. These layers are referred as horizons. Soil profile can also be seen while digging a well or laying the foundation of the building. It can also be seen at the sides of a road, on a hill, or a steep river bank. Let us study the three different inner layers of soil or horizons in detail. So students, are you able to see this picture of the soil profile? What is there in this picture? So, on the top, it is a topsoil or A horizon, and in the second number, subsoil or B horizon. On the third number, it is substratum or C horizon, and the last level is bedrock or D horizon. Topsoil or A horizon. It is the uppermost layer of the soil. It shows the following features. It consists of the particles and is more fertile. It is rich in humus and is therefore dark in color. Humus is formed by the decaying of dead plants and animals. Humus means more organic matter. This layer is soft, porous and holds enough water. The roots of plants are present. The roots of tall tree may go further down to the B horizon. Living organisms like earthworm, insects, bacteria, fungi are present in this layer. Subsoil or B horizon. The next layer of soil called B horizon or subsoil show the following features. This layer is light in color as it has very little humus or organic matter. This layer is more harder and compact than the topsoil. Roots of tree generally reach this level. Substratum or C horizon. The lowermost of the soil is called C horizon. This layer lies below the subsoil. This layer is made up of small pieces of hard stones and rocks with cracks and crevices. It is very difficult to dig beyond this layer. Bedrocks or D horizon. Just below the substratum is the bedrock or pennant rock and also called D horizon. The bedrock is solid and hard layer of weathered rock. This layer cannot be easily dug up when with a spade. Water cannot penetrate the bedrock, so it accumulates above it to form the water table. The reservoir of water accumulated is called groundwater. When there is sufficient rain, groundwater rises, whereas during drought, groundwater level falls. Types of soil. Soil is another abiotic component of our environment. The word soil is derived from the word solum, meaning earthy material. Soil is the uppermost layer of the earth's crust, what we see in the surface of the soil. The top layer of the soil acts as a medium of the growth of plants. Topsoil mainly consists of four kinds of rocks particles. These particles differ in their size, appearance and feel. Clay particles. Clay consists of the smallest rock particles. These small particles are packed tightly together, as a result of which very little air is present in them. Water is held in the tiny gaps between the particles. Silt particles. Silt particles are slightly bigger than the clay particle. The silt particles are of the size from 0.005 m to 0.05 mm. Sand particles. Sand consists of still larger rock particles. Since the particles are quite large, they are not bound closely together, as a result of which there is a lot of empty spaces between them, which is filled with air. The large space between the sand particles allows water to drain quickly. Gravel. These contain the large rock particles. Depending upon the relative proportion of the rock particles and the texture, soil are classified into three main types: sandy soil, clay soil, loamy soil. These are described below. Sandy soil. The soil contains a large amount of sand particles and very small amount of silt and clay particles. Sandy soil is found in deserts. Sandy soil cannot hold much water. Sandy soil is not suited for agriculture. The sand particles in sandy soil are quite large. Since large particles cannot pack themselves closely, there are large number of gaps, empty spaces between them. Such gaps or empty spaces are filled with air. We can call it sandy soil as well as aerated soil. Because of these empty spaces, water can drain through such soil. Therefore, sandy soil is light, well aerated and rather dry. Clay soil. This soil mainly contains small sized clay particles. Sand and silt are present in traces. The characteristics of clay soil are as follow. Clay particles being much smaller packed tightly together, leaving little space for air, so clay soil have little air. Clay soil has very small and tightly packed clay particles, making it less porous, so it has a very good water holding capacity. Clay soil gets easily waterlogged during the rainy season. Clay soil turns very hard on drying. Clay soil is heavy because it can hold more water than the sandy soil. Clay soil is very sticky. Loamy soil. Loamy soil contains an equal amount of sand, large particles and clay, small particles. It contains silt and humus also. It is mostly dark brown and appears slightly coarse. Loamy soil is the best for growing crops because of the following reasons. Loamy soil has a tight water holding capacity necessary for the growth of plants due to the presence of clay small particles in it. Loamy soil has adequate air spaces between its particles to hold sufficient air needed by plant roots due to the presence of sand, bigger particles in it. Loamy soil contains sufficient amount of humus to provide necessary nutrients for the growing plants. Loamy soil can be plowed easily in the crop field. Difference between sandy, clay and loamy soils. So, are you able to see this chart, children? This chart is showing the difference between the types of soils. Property: sandy soil, clay soil, loamy soil. Main constituent: large sized sand particles, smaller sized clay particles. Clay, sand and silt present in right proportions. Space between particles: quite large, quite less, sufficient. Presence of air: well aerated, not well aerated, can hold sufficient air. Water holding capacity: cannot hold much water, can hold much water, right water holding capacity. Nutrients: cannot hold nutrients, can hold nutrients, can hold nutrients. Plowing: easy to plow, difficult to plow, easy to plow. Properties of soil. Three important characteristic properties of soil are percolation rate of water, moisture, absorption of water. Percolation rate of water in soil. You know that pores in soil help the rainwater to seep into the soil. Which types of soil, sandy or clay, will allow more of rainwater to seep into the soil? Let us perform an activity to study the percolation rate of a soil sample. Aim to find out the percolation rate of soil sample. Materials required: soil sample, a glass pipe or a PVC pipe, a stopwatch, water and a measuring cylinder. Procedure: look for a place where a good amount of soil is available, like a park or a garden. Dig at least 2 cm deep in the ground. Now place the glass pipe or PVC pipe as shown in the picture. Measure 250 ml water and slowly pour into the pipe. Start the stopwatch immediately when you start pouring water into the pipe and note down the time. Note the time again when all the water percolates into the soil. You can now calculate the percolation rate of water by using a formula. Percolation rate: milliliter per minute is equals to volume of water milliliter by percolation time, that is minute. Note: suppose the sample of soil taken by you take 25 minutes or 250 ml water to percolate. The rate of percolation can be calculated using the given formula as 250 ml by 25 minutes. is equals to 10 ml per minute. Observation: volume of water taken 250 ml. Percolation time dash minute. Conclusion: percolation time for the given soil sample is dash milliliter per minute. The rate of percolation of different soil sample will be different. Moisture in soil. Soil contains water in the form of moisture. Moisture content of soil depends upon its type and source. The presence of moisture in soil can be confirmed by performing the given activity. Absorption of water by soil. Different types of soil absorb or retain different amount of water as shown by the following activity. Activity shows the water absorption capacity of different types of soil. To measure the amount of water absorbed by the soil, subtract the volume of water left in the measuring bottle from the initial volume of water. If volume 1 and volume 2 are the initial and final volume of water in the measuring bottle, then volume of water absorbed by the soil milliliter is equals to initial volume of water in the measuring bottle milliliter minus final volume of water in the measuring bottle milliliter is equals to volume 1 minus volume 2. Since 1 ml of water has a weight equal to 1 gram, therefore weight of water absorbed by the soil is equals to volume 1 minus volume 2. Percentage of water absorbed. Weight of water absorbed by weight of the soil into 100. The activity of the soil. Now, sand and crops. The sandy soil has a very poor water retaining capacity. It is poor in nutrients. The clay soil has high water retaining capacity, but it cannot trap air. It contains nutrients in reasonable amount. Therefore, layer soil is suitable for the plants which require standing water. The loamy soil has good water retaining capacity. It is rich in nutrients and permits sufficient air. For proper growth, plant need water, air and other nutrients present in the soil. Therefore, based on these properties, it can conclude that the loamy soil is most suitable for plants. Thus, both clay and loamy soil are suitable for plants and crops. Suitability of soil for some typical crops as described below. Wheat and grain, both clay fine and loamy soils. Paddy, both clay and loamy soil with low percolation rate. Lentils, masoor, pulses, loamy soil which drain out water easily. Cotton, sandy loam or loamy, soil which drains out water easily and holds lot of air. Soil erosion. Soil is an important natural resource necessary for the sustenance of life on the earth. However, it is under tremendous pressure from the human beings. The removal of land surface or topsoil is known as soil erosion. Soil erosion is a serious problem that farmers face today. Generally, the rate of removal of fine particles from the surface is the same as the rate of formation of the soil, but sometimes there may be a disturbance in this balance, usually made by men, which may lead to a greater rate of removal of soil. This results in an increase in soil erosion. The main agents of soil erosion are wind and water or rain. There are several factors which allow water and wind to cause soil erosion. They are as follow. Deforestation, removal of vegetation, ill removal or cutting of trees. Deforestation allows water to run off the soil. Soil, due to increasing population of humans, land is required for agriculture, construction of building, roads, dams and industries. Water does not seep down in the soil. Due to deforestation, the soil particles are carried away by water. This problem is serious on steep slopes. The water carries soil particles into the rivers which get choked with silt. The net result is the flood. Since deforestation makes the land barren, wind erosion too takes place. The root system of the plants binds the soil together as well as act as a channel of water to percolate down, thereby preventing erosion. Overgrazing. When cattle are allowed to graze on the same land for a long period of time, they eat up most of the plants or grass of that land. This removes the vegetation cover from the topsoil. This bare topsoil can be carried away easily by rain or wind, leading to soil erosion. Excessive plowing of fields. If farmers plow or till their fields excessively to grow crops, the soil in the field becomes loose and it can be easily eroded by rain and strong wind. Floods and heavy rainfall. Floods and heavy rainfall cause a lot of damage to the soil, especially where there are no trees and the land is lying barren. Forest fires. Forest fire to cause soil erosion. After fire, the soil is exposed to water and wind, causing soil erosion. Prevention of soil erosion. Soil erosion can be prevented by the following methods. Afforestation. The process of planting trees in large number on deforested area is called afforestation. The process of afforestation should be undertaken not only in an area already cut, but additional area should be brought under plantation. Trees and grasses hold the soil in place. To reduce the effect of strong wind in the fields, the boundaries of the fields should be planted with trees in 2 or more 3 rows. Terrace farming. It is a method of farming adopted in hilly areas. In this method of farming, suitable crops are grown on sloping ground, which is cut into large steps called terraces. Terrace farming reduces the speed with which water flows down, thereby reducing the amount of soil being carried away. Terrace farming is also called step farming. Crop rotation. To maintain the soil in its natural condition, it is advisable to grow different crops every year. Crop rotation helps to maintain the fertility of the soil. The water holding capacity of the soil is also maintained by this method. Restricted overgrazing. Overgrazing of a single patch by animal must be avoided. Animals should be moved to a different area after some time. Constructing bunds. Embankment on mud walls should be constructed around hill, slopes or fields to stop water flow. Flood control. Flood can be controlled to a large extent by building dams. Proper drainage and irrigation arrangements. Proper drainage and irrigation arrangements should be made in the fields to control soil erosion. Soil pollution. The excess of fertilizers, insecticides, herbicides, weedicides, industrial wastage, etc. are the factors which are responsible for contamination of soil pollution. There are 2 main ways by which soil becomes polluted. First way is the dumping of non-biodegradable waste, and the second is the excessive use of chemical fertilizers, insecticides, pesticides, etc. Chemical pesticides are non-biodegradable. They accumulate in the soil and water bodies, are taken up by the living organism along with food and then accumulate in the tissues of these organisms. Fertilizers change the structure of the soil or the way of soil particles are held together. Growing the same crop in the same part of land season after season make the soil deficient in nutrients. Soil pollution affects agriculture production by affecting the yield of agricultural crops. Residues of pesticides and herbicides may kill essential soil organisms and thus affect soil fertility. So children, it's time to Reader's Digest. Soil is one of the most important natural resources necessary for life on earth. The breaking down of the rocks into smaller pieces by natural factor like wind, waves, glaciers and rain is known as weathering of rocks. Topsoil is the uppermost layer of the soil. The lowermost layer of the soil is called sea horizon. Soil contains water in the form of moisture. So students, it's time to take your leave. We'll meet in the next class. Bye.